Okay, welcome to your last lesson for this week. Today, what we're going to talk about is direct variation, and that is another way to say proportional relationships. So, we're going to look at a couple examples of where we have what's called a proportional relationship. And I first want to show you how you can identify a proportional relationship by looking at a graph. So, in example 1, my line is a straight line and it goes through the origin, and the origin is the coordinate 0, 0. So if I were to continue out this graph and continue my line in the opposite direction, it is going to go straight through the origin 0, 0. So for example 1, this is proportional. So I'm going to abbreviate that because the line goes through the origin. That is a really easy way to tell if a relationship is proportional. So the number of hours is proportional to the number of miles. And again, if I just eyeball my graph and my line goes to the origin, that's proportional. Now on example 2, this would not be a proportional relationship. My origin is right here. My line does not go straight through the origin. It completely misses it. So this is going to be a non-proportional relationship between the glasses of iced tea sold and the amount that they make in dollars. So that's non-proportional. Now it's important to note that even if your line looks like it's kind of close to the origin, so just like pretend that I have a graph and my line starts, say, like right here, and then it goes up. So that really looks like it could be proportional, but it's not, because as you can see, my line misses the origin, or it misses the coordinate 0, 0 just by a little bit. It's just a little bit above. So that red line would not be proportional. So you have to look at your graph and your line really carefully. So now we're going to take a look at a few tables and determine if the coordinates, or the x and the y, are in direct variation, or if they're proportional to each other. So let's review proportional. So proportional means that basically if you're dividing two quantities, then you get the same fraction when you reduce it. So for example, if I divide 1 by 2 and 2 by 4, these are proportional, okay? Because both of these fractions simplify to 1/2 and they equal each other. Okay, so another example, say that I have 9 over 3 and I have 27 over 9. Both of these fractions simplify to 3. 9 divided by 3 is 3. 27 divided by 9 is 3. So 9 over 3 and 27 over 9 are proportional. So the way that we check if a relationship is proportional, we divide all of our y values by our x values. And if all of those values simplify to the same fraction, just like 1/2 and 2/4 simplifies to 1/2, then we have a proportional relationship. So let's go ahead and check this out. So again, if I divide all of my y values by my x values, and those equal the same thing, then it's proportional. So it says determine whether the linear relationship is a direct variation. That means if it's proportional. If so, state the constant of variation, meaning what is your y divided by x for each value. So let's look at example 3. Okay, so I'm going to divide all my y's by my x's to make sure that I get the same fraction when it's reduced. So for my first coordinate, I have 120 divided by 3. Your y divided by x. And I cannot write today. There we go. 120 divided by 3. Now I know that that simplifies to 40. Now my next coordinate, I've got 90 divided by 6. And that does not simplify to 40. So I can stop right there. I have to have the same value for all of my y's divided by x's for the relationship to be proportional. So this is non-proportional, and that's all I have to say. Okay, let's try one more. So I'm going to check if this relationship is proportional. So I'm going to divide all my y values by my x values and check to make sure that I get the same reduced fraction or the same number. So here I have negative 5 divided by 2, negative 10 divided by 4, negative 15 divided by 6, and negative 20 divided by 8. Okay, so negative 5 over 2 is simplified as much as possible. Negative 10 over 4 simplifies to negative 5 over 2 because I can divide 10 and 4 by 2 over 2. Negative 15 over 6 also simplifies to negative 5 over 2 because I can divide 15 and 6 by 3 over 3. And negative 20 over 8 also simplifies to negative 5 over 4 because I can divide 20 and 8 by 4. And actually, I miswrote that. When I divide 20 and 8 by 4 over 4, what I actually get is negative 5 over 2. So as you can see that I have the same number, I get the same number when I divide each y value by its x value. Now you could put these in decimal form, negative 2.5. That would work too. So what I'm going to say is that this is proportional. And then I give my constant of proportionality, or my constant of variation. And my constant of proportionality is just my y value divided by x, which is negative 5 over 2. And you can write constant of proportionality for that. So it's proportional, and my constant of variation, or my constant of proportionality, is negative 5 over 2, because that's the number I get each time when I divide my y value by my x value and simplify it. So now to finish up, I'm going to do 2 word problems with you guys. And we're going to start off with number 5. And I'm going to do my work for number 5 down below so that way you can easily see it. So it says the cost of paper varies directly. So that means there's a proportional relationship with the number of reams bought. So a ream is just a package of paper, one package of paper. So the cost of paper varies on how many packages you buy. Suppose 2 reams or 2 packages cost $5.10. It says write an equation that could be used to find the cost of X reams of paper. So what could you write as an equation to figure out the cost for any number of reams of paper that you buy? So before I just jump right in, I'm going to make a table just so I can easily see what's happening here. And I've got my reams of paper and then my cost. And I set it up this way because my total amount is going to be my cost, and that depends on how many reams of paper that I buy. So I'm told that in the question, 2 reams cost $5.10. So to figure out how much 1 ream costs, I would just take my $5.10 and divide that by 2 to see the cost for 1 ream. So $5.10 divided by 2 is $2.55. So it is $2.55, or $2.55 per 1 ream of paper. Okay, and I'm told that this is a proportional relationship, so that means that that cost is going to stay the same. It's always going to be $1.55 for 1 piece of paper, or $2.55 for 1 ream of paper. Okay, so part A is said to write an equation. So basically, what my equation is going to be is that my my cost, or my total cost, is going to equal $2.55 times however many reams of paper that I buy. So for example, if I buy 1 ream of paper, my cost is going to be $2.55 times 1, or $2.55. If I buy 2 reams of paper, my cost is going to be $2.55 times 2, or $5.10. If I buy 10 reams of paper, it would be $2.55 times 10, and so on. Okay, so it says find the cost of 15 reams of paper. That's part B. So to find the cost of 15 reams of paper, and I'm asked to use my equation, I'm going to use my equation of cost equals $2.55. And if I buy 15 reams of paper, I'm just going to multiply $2.55 times 15. And what that gives me is $38.25. So my total cost is $38.25 for 15 reams of paper. Okay, so that's example 5. So for this last example, we're going to do the same thing, similar to that last question. It says, recall that the length of a spring stretches varies directly with the amount of weight attached to it. So what that means is that the length of the spring stretches based on how much weight you're putting on that spring. A certain spring stretches 5 centimeters when a 10-gram weight is attached. It says for part A, write a direct variation equation relating the weight X and the amount of stretch Y. So the first thing I'm going to do is set up a table to organize my information. So this is for part A. So on my table, I'm already told that the weight is going to be represented by X. And I'm told that the stretch is represented by Y. And if you're wondering where I'm getting that, it is just from reading this right here. The weight is X and the stretch is Y. Okay? So I'm going to use now what I was told in the problem, and that is that my string stretches 5 centimeters when a 10-gram weight is attached. So when a 10-gram weight is attached, my string stretches 5 centimeters. So that's just my information. Now I'm going to find my constant of proportionality. So I'm going to divide my stretch, which is 5 centimeters, my Y value, divided by my weight, or my X, which is in grams. And again, remember that to find your constant of proportionality, you need to divide your Y value by your X value. Now I'm going to simplify this so that I can figure out how many centimeters does my string stretch for every 1 gram. So I'm going to divide by 10 over 10. Okay, so 5 divided by 10 is 0.5 centimeters, and 10 divided by 10 is 1 gram. So what that means is that my string stretches a half of a centimeter when you add a gram of weight to it. So my equation is going to be this. The total stretch is going to be 0.5 times my weight. And if we wanted to check that, we could easily just look at our table. So my example, my weight was 10 grams, and when I multiply that by 0.5, I get 5 centimeters of stretch. Okay, so part B, it says estimate the stretch of the spring when it has a 42-gram weight attached. So my total stretch is going to be the half times 42. And 0.5 times 42 is 21. And that's going to be in centimeters because we're talking about the stretch. Okay, so that's all for today. If you have questions, message me. And I hope you guys finish up all your work for the week. And again, if you're stuck on something, just message me or come to our Zoom meeting today. All right, thanks for watching, and I'll talk to you guys later.